Go ahead.
So this is my West Point bridge design. For the design brief, the client company is Hard Hat Incorporated, and their target consumer is going to be like for civilians. Lead engineers was me. Problem statement was to build a sturdy bridge for the cheapest cost to make it possible for truckers to move shipments more efficiently. Design statement, just building a bridge with the use of trusses with like the lowest cost possible. The criteria and constraints had to be at the minimum cost, deck height, I should say 24 meters. The bridge height had a max of 32.5 meters, and I didn't read through the whole thing, but I saw a part with no piers and anchorage points for constraints. And then these are my bridge designs. So the one on the left is design number 1. I based it off of the given example in the book. I figured out that one did not work at all for me. It kept falling apart in the middle. So with all these joints in the middle, it was to help support the tops from either concaving or convexing when the truck would go through. This is my second design. It kind of copies that design but with less members and joints, and it uses the anchorage points, and they both used the cheapest metal there was, which actually did not help me in the long run. That being, the bridge number 1 was $556,537.88, 70 members, 36 joints, and I just used basic box and triangles like bridges you would see on highways and stuff. And then for bridge number 2, I used carbon steel again, but this time I used 2 anchor cables. I used smaller boxes and triangles than what I did with the first bridge. The total cost was $929,061.31. The cost is increased even though I used less members and joints. It's due to the cable anchors and the strength of the concrete. For the second bridge, I used the high strength. So for the anchor cables, the base cost was $75,200. And bridge number 1 was like $63,200. And then with the high strength concrete, it actually added $4,400 more to the build. That's fun. Almost had it. So close. So the first video on the left of this is bridge design number 1. It gave a lot of flex in the middle. That's why there's a lot of supports there attached. A lot of them were in a V-shaped formation. And then with my second bridge design, the cable anchors actually helped it kind of stay level and not flex as much in the center. And that's it.
All right. Nice job.